when you're looking at a reaction to try to, figure out what type of reaction it is, and in this case, whether or not it's redox, well, this now you need to focus on charges, on the oxidation number. So basically, a redox reaction is any reaction where one element's charge goes up or is oxidized and another element's charge goes down or is reduced. It's also known as an oxidation-reduction reaction, and to figure out if the reaction will even occur, you use the activity series, which is the list of elements listed by increasing activity on the star chart. So looking down here, I see that zinc is trying to react with hydrochloric acid. And so we need to figure out, will zinc be able to replace hydrogen in hydrochloric acid? So you look at your activity series and you need to check, is zinc higher on the list than hydrogen? And in fact it is. So this reaction will occur. And one of the reactants, or one of the products that you're going to produce, is the pure hydrogen gas. And hydrogen is Brinkelhoff, so it's going to be H2, and that will be a gas that will be released. And this is the gas that we use to blow up the egg in the day of demos. And the other product that we're going to produce, zinc, when it bonds, is going to have a +2 charge. Chlorine, when it bonds, is going to have a -1 charge. So this compound is going to be ZnCl2, and it is soluble, so it will be aqueous. And now we can balance it, and it looks like all we got to do is put a 2 right here. And then to figure out whose charge went up and whose charge went down, just simply write the oxidation numbers for everything. So zinc in its pure state is going to have an oxidation number of 0. Hydrogen in hydrochloric acid is going to be a +1. Chlorine is going to be a -1. Now coming over to the products, hydrogen is going to be a 0. Zinc, when it's in a compound, like we said down here, is going to be a +2, and chlorine, like we said down here, is going to be a -1. So zinc went from 0 to +2, so zinc's charge went up, so it was oxidized. Hydrogen went from a +1 down to a 0, so hydrogen was reduced.